All right, question number 4. We want to determine the graph of a function that is 1 to 1 on the interval negative infinity to negative 2, but is not on the whole domain, negative infinity to positive infinity. So as I'm looking negative infinity to about 2, this is not 1 to 1. It will fail the horizontal line test. Looking at graph B, this one does show that it is 1 to 1, but it's 1 to 1 everywhere, like the whole graph is, and we need it only to be from negative infinity to 2. So I'm just imagining drawing horizontal lines. So C, if I look at this graph, negative 2. Okay, so negative 2 is the axis of this parabola, and so that's going to work out perfect. It's going to be 1 to 1 from negative infinity up to this point. But when you start going past negative 2, then you will cross a point twice and it will fail. So C is the graph that we're looking for. All right, number 5, we want to find 4 intervals which this graph F is 1 to 1, and we want them to be as big as possible. So again, you cannot cross a line twice, and this graph goes off screen, so that means negative infinity. We want to do this in interval notation, so negative infinity up to the point 5. And so it looks like this graph does reach 5. So we want to put that in a bracket. So you just hit the square bracket. And then after 5, it is 1 to 1 until we get to the x value of 2. So negative 5 to negative 2. And both of those will be in brackets. We reach both of those points, negative 5 to negative 2. Also, it's very important that you put these in numerical order from smallest to largest, and I did miss my negative 5 here. Make sure you do that because it will count it wrong if you have the right numbers but they're out of order. So they got to be in order. Then it picks back up 1 to 1 from negative 2 until we get to this point, positive 1, also in brackets. And then from positive 1 to infinity, and we will put the 1 in bracket in the infinity in the parentheses because we do not reach infinity. We're always going toward it.